Hello, this is our video presentation for Artificial Intelligence IA2. Myself, Keyur Patil, along with my teammates Rikhav Satra, Aman Sayed, and Keshav Pandya. The topic for our presentation is customer segmentation using clustering. So, moving with the problem that we are addressing. In many businesses, understanding customer preferences is crucial but also difficult. Without proper segmentation, marketing strategies often fall flat. Our goal is our goal was to solve the problem. How we can segment customers based on their behavior, improving the market and retention. Moving on to our objectives. To segment small customers based on their spending behavior and income, to to use different clustering algorithms to identify distinct customer groups, compare the effectiveness of this algorithm, and finally derive insights that businesses can use for smart marketing. Uh, Moving on to the dataset use. We use small customer segmentation dataset from Kaggle. It has 200 customers, including their customer IDs, their gender, age, annual income, and spending score. The spending score is a score assigned based on their behavior. Uh, our dataset is a popular dataset that is used in real industry for clustering analysis and customer profile. Moving on to the tools, techniques, and how the working. For this project, we use Python and several libraries, namely Python and Pandas and NumPy for data handling, Matplotlib and Seaborn for data visualization, Scikit-learn for clustering, and Neat for identifying the optimal number of clusters. Now I will pass on to Aman for explaining the implementation details. Thank you.
So all of the code can be found on our GitHub. I'll switch over to the Python notebook, and we'll go over the customer segmentation using clustering techniques. I believe Keshav will start. Keshav, mute.
Okay, so for customer segmentation, we are using three techniques mainly: K-means, DB-scan, and agglomeratic clustering. So moving ahead, we'll start with the pre-processing part. And for pre-processing, before pre-processing, we are importing some frequent used Python libraries such as NumPy, Pandas, Seaborn, Matplotlib, and etc. as discussed by Q. So we read the CSV file using pandas. Moving ahead, this is our CSV file in which the features are customer ID, uh, gender, age, annual income, and spending score. Moving ahead, basic info. If the For pre-processing, we firstly check if the features are null or not. So the shape is there, like we have 200 data, 5 columns. Okay. For the dataset, we firstly drop all the features which are not required in training or segmenting the proper model. We are using k-means. Moving ahead. Okay, so we demonstrate the application of k-means on this data set using annual income, spending score as features. The goal is to segment clusters into distinct groups for targeted marketing strategies. We are using two features mainly: annual income and spending score. So in the x variable, we have stored both the features. The clustering score is calculated in the different iterations. Moving ahead, yes, we have used elbow method to get the most optimal number of what do you call it? Most optimal number of clusters to be for the data set to be clustered. In this line of code, we have applied the k-mean clustering, and then we have predicted the output. These are k-mean clusters. There are centroids of the clusters which are calculated. Then uh, we have visualized every iteration using the function. Uh, these are the five centroid centers for the five clusters which we have created in the above code. Using Matplotlib, these are the five clusters and the centers located on the graph. Yes, this is the function for each iteration in which we are displaying every iteration of the clustering. Okay. These are all the intermediate steps involved in k-mean clustering. Yes. In each step, the clusters are measured using the distance of a particular data from the centroid, and then again the centroids are changed. This is the centroid movement, as you can see on your screen. The clusters and the centroids are moved every iteration. Okay, from the DB scan clustering, I'll pass the baton to Aman.
Thanks, Keshav. I'll be going over the DB scan clustering. So, DB scan stands for density based spatial clustering of application with noise. It is a clustering algorithm that points together points that are closely packed while marking points in low density regions as outliers. Unlike K means, DB scan does not require a specific amount of clusters to be made. It relies on two parameters, the EPS or episodes in the neighborhood radius and the minimum number of samples required to form a dense region. The main difference between the DB scan is that it does not require a pre-computed amount of number of clusters. Like we use the knee point there to calculate the appropriate number of uh, clusters. It does not require it. So let's go over with the implementation. First, we import all the necessary components from the libraries. Then this DB scan requires a normalization of the database. So we use scikit-learn and import the standard scaler and standardize it. And we run the DB scan function. Then we appropriately allot a cluster data frame to and export all the amount of values, and then we'll move on to the visualization. So the main point of DB scan is the noise is classified as the value of -1, which means that it does not belong to any of the uh, appropriate allotted clusters. So we can see this is the DB scan clustering. We can see cluster 0 red, majorly of the marking, cluster 1, and then rest are allotted as noise. So we can see this is not giving appropriate clustering, and the only two number of clusters are there. So we will try to fine tune the model, and we'll tune the EPS, neighborhood radius, in the k distance graph, which is a standard method to find a good EQS. So this in this code we store the distances by and we store them, and we locate the knee point, and we try to plot the graph again. So the estimated value of EPS was 0.654. Now we apply that to the data set, and this is the amount of clustering we get. This is fine-tuned data set, and again we can see some of the blue dots are characterized as noise, and the rest are appropriated into majorly 4 clusters. Now again we try to get better results from the DB scan by applying dimensionality reduction. We use principal component analysis (PCA), which makes it easier to visualize and clutter the data effectively. We apply two components, and we use nearest neighbors to find the dimensionality clustering. But again, we can see DB scan is not giving the correct output and the desired number of clusters for this data set. So we can assume that DB scan is not good on this specific data set. Let's move on to hierarchical clustering and Gaussian mixture models. Hierarchical clustering organizes data into a tree-like structure, which is a dendrogram, to identify clusters, while Gaussian mixture models assumes data is generated from a mixture of Gaussian distributions. Both are alternate approaches to segment customers and offers insight into data structure. So let's use scikit-learn and try to create a dendrogram and a linkage, where I believe we're using minimum distance dendrogram for hierarchical clustering, and we can see this is the dendrogram formed. So we can see the number of a lot of different uh, clusters are clustered together to get the number of linkages, and then in the agglomerative clustering we can see it is successfully able to visualize and show that it is divided into five main clusters. Let's go over Gaussian mixture models. It is a probabilistic clustering algorithm that assumes data is a mixture of Gaussian distributions. It provides soft clustering where each data point is assigned a probability of belonging to each cluster. Now, one of the major disadvantages of Gaussian mixture model, it is very computationally expensive compared to k-means, which just uses the Manhattan distance or the Euclidean distance. So we import the Gaussian mixture function, and we allot the data frame, the property, and we can see this is the result we get. So now over to the results and analysis. I'll switch back to the PPT where we go over it.
Okay. So we applied four clustering techniques: K-means, DB-scan, hierarchical clustering, and GMM. So K-means gave us five very clear and well-separated clusters, making it most effective method. DB-scan identified dense areas in the data, but struggled when clusters were close together. Hierarchical clustering showed up a visual a tree-like structure of relationships, which was useful for small data sets. GMM used probability to assign customers to clusters, which worked well when customers belong to overlapping groups. Think of it like trying different ways to group students by height, by subject preference, or by how much time they spend together. Each method shows us different view of same class. Okay. Uh,
Now, next slide. Yeah. No, no. Pros and cons. I'm sorry. Yes. So each clustering method has its own advantages depending on the problem. K-means is simple and fast, but it assumes that the groups are circular in shape and requires us to choose the number of clusters in advance. DB-scan doesn't need that. It can find groups of different shapes and even identify outliers, but it's quite sensitive to the parameters we give it. Hierarchical clustering gives it clear tree-like structure showing how groups form, but it doesn't scale well for bigger data sets. GMM offers flexibility by allowing overlap between groups, but it needs more careful tuning. So, just like choosing between a bike, a car, or a truck, depending on the journey, each algorithm fits best in this particular situation. Next slide. Yeah. So, in these slides, you will see how each algorithm formed customer groups with K means, as we see, five distinct clusters appeared based on income and spending habits. Can we move on to DB scan? So DVScan highlighted dense regions, but also marked some customers as noise. Hierarchical clustering. It built a visual map of how groups merge. These visuals show us how each method sees the data differently, like coloring dots where each color represents similar spending behavior. It makes the abstract math behind clustering easy to understand through images. So now we'll move on to the real world applications. Customer segmentation is widely used in real life. Retailers use it to suggest the right products to the right people. Healthcare providers group patients by medical risk for better care. Advertisers use it to show more relevant ads. Think of how Netflix recommends shows. It understands what kind of viewer you are and suggests content accordingly. That's customer segmentation in action, helping businesses create more personal and efficient experiences. So to sum it up, clustering helps businesses turn simple customer data into valuable insights. By grouping people based on spending patterns, income, or age, companies can target their services. This not only improves customer satisfaction but also boosts business performance. It's like organizing books in a library by genre instead of randomly. When things are grouped meaningfully, everything becomes easier to navigate and much more effective. So our project shows how AI can power this kind of smart organization. That brings us to the end of our presentation. Thank you.